Welcome to Engage Math, Lesson 25, Problem 2, where we are solving equations that involve a square root or a radical. And the way that we are going to do this process is the way we always solve equations, where we do the same operation to both the left and the right side. But it's really important that you see that in this case, we have to check for extraneous solutions, because what we're going to do is we're going to square both sides of the equation. So we're going to actually check our answers at the end to make sure we've done everything right. So if I square the left side, I have to square the right. So I'm going to get 3r plus 1 equals 49. So we subtract the 1, so we'll get 3r equals 48. Divide by 3, so r equals 16. Now, if you were to put 16 back in for the r, we have to check this time. You will see that it actually works perfectly, because 3 times r is 3 times 16 is 48, plus 1 is 49. The square root of that in the original equation is 7. 7 equals 7. R equals 16 is a valid answer. It checks. It works. Now, the reason we have to check is sometimes when we square both sides, we may miss the fact that we actually are squaring a negative, and it's going to change the viability or the accuracy of our answer. It's not really not being accurate. We've done all the work right, but we can get what's called an extraneous solution. So let's get started. First thing we're going to do is divide both sides by 2. So we have the square root of x minus 3 equals negative 2. So I'm going to zoom in a little bit for this so you can see really clearly what happens. Now I'm going to change our color so we can see that if we square both sides, we end up with x minus 3 equals a positive 4, add 3, so we get x equals 7. But the problem is, if you put 7 in for x, you'll have 7 minus 3, which is 4, and the square root of 4 is 2. So we end up with 2 times 2, because this becomes a 2. So and it's a positive 2, but it's just 2 times 2, which is 4. But wait, a positive 2 times positive 2 is a positive 4, and they're telling us it's equal to a negative 4. So this problem has no solution. And the reason it has no solution is because when we put the answer that we got, even though we did all of our work correctly, we showed that it didn't work in the original. But I want to show you how we can actually see that right off the bat at the beginning. So here's our original equation. If you notice that when we divided both sides by 2, sorry about that, we got the square root of x minus 3 equals negative 2. The square root symbol means the positive version, the positive or principal square root. It means it's going to be a positive number. So the square root of x minus 3 times 2 could never equal a negative. So we could tell right away that there's no solution, but a lot of times students miss that at the beginning, or it's hard to identify. So make sure you check your answers when you square both sides of an equation, which we'll do in C and D. All right, let's go to C. Our first goal is to subtract 4 from both sides. So I'm not going to show all those steps, but I am going to just tell you that we're going to get 27 on the right. Now we're going to divide by 3. So we have the square root of 2x plus 8 equals 9. Now is when we do the squaring both sides. So I'm going to square both sides, and I get 2x plus 8 equals 81. 2x equals 73. And x is going to be equal to, now keep in mind that 37 would be doubled, would be 74. So we only want 36 and a half to be our x. So I'm doing a lot of mental math there, not showing all the steps as you move on in algebra. Okay, so 36 and a half, if we were to put that back into the original for x, we would get twice that, which would be 73. 73 plus 8 is 81. The square root of 81 would be 9. 3 times 9 would be 27. Plus 4 is 31. You could check again, but that answer works. Okay, let's go to D. All right, so for D, the first thing we're going to do is divide both sides by 3. So now we have the square root of b minus 1 equals 3 times the square root of 2b minus 19. We didn't have to do that step, but it just makes all of our numbers easier to work with. So now we're going to square both sides. And when we do that, we're going to get just b minus 1 on the left. And on the right, we're going to get the 3 is going to be squared because there's really an exponent of 1 there. So we're going to get 3 squared. 3 squared is 9, so it's going to be 9 times the quantity 2b minus 19, because the square root of 2b minus 19 squared is just 2b minus 19. So now we have a new equation, b minus 1 equals 18b minus. Now this is not a calculator problem, so the easiest way to multiply 9 times 19 without a calculator is either to write it out the good old-fashioned way, or, and let's just do it that way for a minute. So that's going to be 81. So you carry the 8, and then you do 9 times 1, which is 9, plus 8 is 7. So we're going to get minus 171 here. But an easier way to do it might be that 9 times 20 would have given us 180. So 9 less than that would be 9 times 19, which is 171. Okay, let's keep going. Lots of ways to do things without the calculator, but sometimes it's a little tricky, especially if you haven't done it in a while. All right, now we're trying to get b alone, so we're going to subtract b from both sides. So I'm going to get 17b on the right, and on the left, I'm going to get 170 because I'm going to add 171. So without showing all that work, b is equal to 10. All right, we have to always check to make sure it works. So we're going to do a little mental math up here. When we put the b, the value of 10 in for b, we're going to get up here, right here, we're going to get 3 times the square root of 9, which is 3. So it's 3 times 3 or 9. So on this left side, we get 9 when we put the 10 in. On the right side, we're going to get 20 minus 19, which is the square root of 1, which is 1. 9 times 1 is 9. Both sides work. B equals 10 is a valid answer. Okay, don't forget to check your answers when you could possibly end up with an extraneous solution because you squared both sides. Okay, great job. We'll see you next time at Engage Math.